Hello and welcome to this fourth EURONAVAL talk, a series of talks that was initiated in 2024 to keep the conversation going between the different iterations of the EURONAVAL show. Now, the previous roundtable, the number 3, which you can find online on the EURONAVAL YouTube channel, we started discussing a little bit about what it was to start projecting at sea, to start having theaters of operations away from sea, and we discussed what it was like to keep this the autonomy at sea for when going long distances for a long time. Now we're going to start moving slowly towards confrontation, which is the theme of EURONAVAL 2026. And we're going to be discussing what it is like to maintain maritime domain awareness in the space age. What does this mean? It means that in a world where we have basically sensors everywhere, under the sea, above the sea, and in space, does this mean that it's making the naval domain more or less transparent? Does it mean that it's going to be harder to hide at sea, so to speak? And what does this mean also in terms of the tools that we can use to have a better sense of what's going on in our oceans? And also all the data that we're gathering, what happens with that, how much we can trust it, and how we make sure that we can trust it. So without further ado, I would like to introduce my 2 speakers today. I have with me Maria del Mar Pomares, Senior Business Development Manager, Maritime System at Indra in Spain. Welcome, Maria.
Thank you very much. Hello, everybody.
It's a pleasure to have you here. And then I also have Commander Maxence Lecire, Digital Strategy Officer at the French Navy HQ over the last 5 years, correct?
Thank you. Yes, correct. Yes. Good morning.
Good morning and welcome to this talk today. So I would like to, as I said, I would like to start off, dig into the heart of things, and I would like to start with you, Maxence, because you've been out there before. My premise at the beginning when building this roundtable was that with all these sensors everywhere, it's making it harder and harder to hide at sea. Is that actually true, or are there nuances to this?
Well, well, it's getting a bit harder, but it has always been hard to hide at sea. First of all, we always have assets and flotillas and the carrier strike group hiding from different competitors and different adversaries. But now what's changing today is that obviously with the increase of sensors that you get, especially in space, and the access of this kind of technologies today, it's easier to get access to the information that gets you some kind of insight of not necessarily per se where exactly the carrier, the ship is, where he might be, or where he used to be, or where he could be in the near future. So this is really a big challenge, and we are addressing it today. We are also using it as an opportunity because this access of sensors, especially in space, is also useful for our operations. And we've been using civilian imageries and on combination with military imageries for our own operations, yes.
So we're seeing more and more of this data fusion between, I mean, we've always used space technologies, right? But now we're also accessing new ones and technologies also that allow us to see ships that turn off their AIS and things like that, right?
Yes, this is one of the main aspects, but the first aspect towards which we have gained access to this information. We have had lots of opportunities to get the sightings of civilian vessels. All the ships, all the fishing vessels have a transponder. It's called AIS. Everybody knows that. And some smugglers are turning it off. So the first trick that we had was to see and to detect from space the fact that the fishing vessel was turning off or smuggling or trying to trick this transponder. So to do so, we first get the signal using satellites information and also internet. You probably know about Maritime or 𝗘𝗂𝗍𝗃𝗹, this kind of websites, and data fusion and data providers. And more, we use algorithms to detect patterns that the smugglers or the navies are using to try to delude to hide their ships in the open seas. And using that over the last few years, yes, we get very, very significant results using this kind of algorithm and data fusion to find and track smugglers and illegal fishing vessels.
So that's when we're talking about civilian vessels that are trying to hide. What about when we're talking about confrontation at sea, and when we're talking about an adversary? That can be, I mean, as we've seen, we can talk about an adversary that has a very developed fleet, and we can talk about an adversary that has different means. So are these technologies also helping in that sense?
Well, if you want to track a military vessel, a military asset, first of all, most of them will, at some point during their transit or during their patrol or during their deployment, use the AIS because they go through checkpoints.
Yeah.
So you can see them when they do that. When you are on an open seas, hiding and really in a confrontation, usually when you're a stealth vessel, you try not to use the AIS. So you need to use other systems like electronic warfare systems to still get the information about where this vessel might be, where he actually is, but not using something as obvious as a transponder.
Makes sense. Now, Maria, Indra makes all of these systems that allow us to see what's out there, see what's happening above the surface. What does this mean? What have you seen in terms of data fusion, in terms of all of this, how it's helping having a better sense of domain awareness?
First of all, I would like to differentiate data from the surface and data from the seabed. Surface is easy to see. They are visible data. They come from sensors such as AIs, synthetic aperture radar, electronic warfare, electro-optical systems, everything is easy. In the seabed, the things change. And here is where the submarine technologies we can prove. For example, we have data for hydroacoustic systems, underwater vehicles, buoys. All of this information needs to be fused. But not only, the point here is we have to fuse military and civil data. And how to connect these two worlds, because the data are different, the way they use the data are different, there are not standard for the civilian parts, for example. And here we have to have a framework or some legal aspects or standards that make the fusion able, because of course the algorithm, artificial intelligence are useful, not useful, are essential to manage all this big amount of data, but a framework where we can say, for example, the civilian partner normally are legacy systems that they were not used to integrate the operation in a cloud. They are not in an interoperable way. They are used to be making a standalone way. So the different make of function are different from the military and the civil part. So the data fusion is the key point here. Of course, Indra is has experience in this domain, in the command and control, and in electronic warfare about all. This is the main point here.
So I have quite a few questions about this thing, about using civilian infrastructure and civilian data from under the seabed. But before we go under the water, I wanted to check, because when we're using space data, aren't we also using civilian data, or is it military data that we're fusing when we're using the space?
Normally, imagine this example. If data from ACE and synthetic aperture radar correlate, then confidence arises. If the opposite occurs, there is no correlation, a human decision takes to be placed. So the information from satellite is not only for military aspects, also for civilian.
Okay, but we are used to fusing military and civilian data when it comes to above the surface.
Is the purpose.
Yeah.
I don't think that this is in the shortest term. I think that is for following years, because there are many constraints. There are different type of data, and all of this makes difficult to fuse all this information. The key point here is know who has the more data, who is able to watch more than anybody. The key point here is who is going to be able to fuse the data and to have the data at the speed of relevance, that we can have a real operational advantage with all this data.
Okay, and coming back underwater, what kind of data would we like to be using from the underwater domain in the civilian world? Anything?
Anything can help us to make a real maritime picture. The problem is that the civilian partners who have the big amount of data, they are not used to share this information. This is a balance. If probably they could share this information if they can help, they can have some type of security. But for the security aspect, we need data. At the end, this is a win-to-win scenario.
Okay. So, Maxence, I wanted to get back to you because I had actually seen a very good presentation from one of Maria's colleagues during UDT 2026 about fusing all this data from the commercial domain and the military domain. I was wondering if in the military world, is this also a conversation you're having? Sometimes, I'm just wondering because sometimes we have a conversation that is happening in the commercial domain and in the industry, and maybe the military is thinking, are we going too fast, or is this a good idea?
Well, we've always had, over the last few years, we have used civilian assets, especially regarding access to space. First, for satellite communications. Obviously, we have military satellites used for military communications, but we use commercial service providers also. Same goes for the imagery, because the civilian market is huge. The data provided by civilian usage are enormous, so it would be damaging not to use all this data that's available and to use it, to cross it with military algorithms to find some assets that we need to find that are really specific. So we try to cross these two aspects with different success. Sometimes it's the military grade system is more powerful, but when you want to use a large coverage, a large area, you need to get lots of data, and for that matter, using civilian data and civilian imagery is very useful. The physics of the ocean is quite stubborn. It's huge. So when you have an asset, a patrol vessel deployed in one area, and you have a few assets to deploy, or only several and only several airplanes, you have two options. Either you use all the data that you have, and you might have something. You're not really sure, but at least it's something. And so that gives you a first information to be more specific with your patrol vessel or your aircraft, to get the proper information and to really get the information that you need. Whereas you can not use the data that's available in the civilian industry, and then you go, just the ship is living at sea, but without any information. When I was in French Guiana a few years ago, we used civilian data provided by civilian websites to get some areas of patrol and some ideas of the area of patrol where it would be relevant to find illegal fishing vessels. And this is the way that we managed to get a ship that was in illegal fishing action, using the bit of data that we had, which was available for free. Which is less expensive and more accurate sometimes than some military-grade imagery satellite that we can't use on all the circumstances.
Okay. So Maria took us underwater as well. And so I know that there's a conversation going in terms of using also data coming from critical infrastructure and all of that. Is this also a conversation that you're having, for instance, in the French Navy?
Well, first of all, for under the water, well, there are several things. The depth is very big, so we always had some sort of use of data for anti-submarine warfare. We get the temperature of the depth of the column, and we see how the wave will propagate inside the ocean. What you were mentioning is how can we use assets that are deployed on the seabed to get some sort of detection. The assets that we use, but that we all have in the most, is the cables, underwater cables. So, is it possible to get an underwater cable to detect something? There's something that is not really a capacity that we have today. Obviously, these are kind of technologies, like all sort of technologies that we are looking into. The other aspect for the underwater cable is that you need all the information that we have. You mentioned, Maria, data beforehand. All the data that we use, for instance, the imagery that are coming from the civilian world, they will at some point go through the underwater cables. So using assets to detect when this underwater cable is broken or malfunctioning, the operators are working on it. But it's not per se the same technology that will be used to detect something under the water.
Yeah, well, I would like to point out this is what is called Internet of Underwater Things. Is to the network of all the assets that is in the seabed domain. In our case, we are studying how to use the information that can provide the fiber optics for communication. The only cable is able to detect some anomalies in the seabed. So we are making studies with this, and this data is also a component for the total fusion, for to have a maritime awareness.
Okay, so you started mentioning the idea, the issue of trust in the data. Could you tell us a bit more about this? What does it mean, and what are you doing to work on that?
It's difficult to answer that question because, as I have told before, civilian partners are not used to standard their data. Probably in the past, the legacy systems were created to work in a standalone mode, so they are not used to share the information with anybody. So they are not protecting for cyber attacks, and the quality of the data vary a lot from one industry to another. So that question is difficult to answer right now. The good thing is that I think that in the future, in the following years, we should close the gap between the technology and between the governance, because the technology is going to run quickly than the governance. And for sure, the following systems that are going to be produced for the seabed are going to be produced thinking about the future and thinking about these standards, but right now they are not. So the quality of the data are not good, and to introduce in a command and control system a data that have errors produce more errors than benefits. So I don't have an answer for this.
A tough conversation.
Yes.
What's raised by this remark is really the fact that the more data you want to cross and use, and the more insight you want to use using different data, the more open your architecture and your data protocols need to be. This is something that we've tested with our embarked data hub over the last few years. We see that the sooner you get data open to have some other developments, well, the better you can cross it and gain some new information, and information that you did not reckon that you had beforehand. So this is really the challenge beforehand, is really to get open architectures, open protocols, and to have an environment in which all this data can be crossed to gain the insight that will give us the leverage against our adversary.
Okay, so just to make sure I understand this correctly, you're telling me that, at least for now, we're talking about the French Navy, since that's who you represent. In the French Navy, this is a conversation that you've been having, the use of data from all sorts of different sources, and therefore that's what we call in French the data hub embarqué, but we're trying to translate this in English as a sort of
Data hub,
cloud or data hub. Yeah, exactly. So what is this? What is this data hub?
An embarked data hub is a sort of computer inside the ship. Most of the ships on the carrier strike group are equipped or fitted with this technology. And it's a place or an environment in which we can gather all the data coming in from different sensors, different systems, and cross them using state-of-the-art cloud technologies. This is what we call an embarked cloud, because it uses piles of technology coming from the cloud industry. So we take all the developments coming in from several providers and all the things that we use on the internet, and we use these assets, these tools, these softwares to create new softwares and to get information that we didn't have before.
But what about data sovereignty? Are you able to, in Spain, for example, the MOD has the data that is not sharing with the Guard Coast, is not sharing with any other agency? How do you deal with this?
Most of the data that we get from our system, the Navy is proprietary, has the propriety of its own data. So step by step, connector after connector, sensor after sensor, we gather all the information. And when you use all the data that are available on the internet and all the data that's already available, for instance, from maintenance or for all the data that we already gather on the Excel sheets, for instance, for all the engine characteristics, the number of hours that you use the engine, the number of miles that you've done, the speed at which, all this data is already available. It's already filtered, but using an Excel file. So if you put just the right amount of technology and this embarked data hub, then you can get access to the information, the raw data, on the first hand, and then you can automatize this system and have predictive maintenance, for instance.
Okay, so you've been talking about predictive maintenance, but we're also talking, from what I understand, we're also talking about maritime domain awareness. So this data hub embarked data hub, we'll get there, also includes data that is not military.
Exactly.
Yeah, okay.
For instance, for all the maritime domain awareness, because it's the subject, the way we put it was, we used to have maritime surveillance. So you had to have someone in front of the desk and to look at the data and to cross the data, to read the data that was available. Using this kind of technologies, we get to maritime vigilance. Actually, you get agents, AI agents, robots, compiling and reading and analyzing the data automatically. And this is at the point at which you gain more background and more insight, because part of the thing that you used to do manually is done by artificial intelligence, and you give some sort of decision level, or at least at the analysis level, to an AI, to an algorithm. But to do so, the AI needs a lot of data to start working, to start thinking by himself. An AI needs first quality data, like you mentioned beforehand, and lots of them. So the first step that we are going through is gathering all the data, annotating all the data, making it, providing it the right quality, and then we put very simple algorithms, and this gives us the first level of insight and of automatization. And we see that in the near future, we will be more and more involved in these developments, and we will have more and more AI agents helping us, helping the sailors to do tasks for which an AI is capable now.
Okay, I'm glad you mentioned AI. I was going to get to this. I know that when we were preparing our talk for today, we also had a chat about the issue of AI. I mean, the usual expression is garbage in, garbage out. I'm not saying there's garbage going into this embarked data hub, absolutely not. But how do you make sure that your AI has not been poisoned, has not been tampered with, and that you can trust it, and you can trust the data that's going in?
Well, when the data is coming from your own ship and from your own sensor, obviously you know where it's coming from, so you know that it's quality data. Where it's more complicated is when you use pre-trained models, open source models that are available on the outside world. So the task that we have is that we need to develop or at least master these technologies, the frontier models, and to make sure that the data that you want and the data that you use and the algorithm that you use won't be biased and won't have that you master his behavior. This is really challenging, obviously, but in the end, when you master this technology, you can also determine and know in which circumstances you allow your AI to be more hallucinative. Because you know, and because you don't really need the sort of really high-grade quality data that you want. So you can balance the different approaches. And most of the time what we say is that you will have a sort of hybrid environment in which you will have very specific algorithm, very military grade, very trustworthy. And sometimes just to have a look at what's going on in the outside world, you'll see it's always interesting to see what your enemy, to see the world with the shoes of your enemy.
Okay.
So using an open environment, an open AI, you can see how an open AI is behaving.
I'm fascinated by what you're saying, but I'm not entirely sure I understand it. How do you mean knowing what your enemies?
Well, if you all the open, let me put it another way. All the AI that we use, all the open source AI that we use, they are projecting and they have some sort of biases.
Yes.
So this is, in a cognitive aspect, this is the way that your adversary or your enemy might see things.
Okay.
If you have another AI, your own AI, you see things the way you want it. You want to see things. It's always interesting to take a step back or a step sideways, to use these kind of environments and to use these kind of AIs to see your environment through the eyes of someone else.
Okay, so we're talking almost about open source intelligence in a way, and also almost like human intelligence.
Well,
I mean, we're talking about AI and human. It doesn't seem to go in the same sentence, but you know.
Both at the beginning, an AI is trained on data that's provided on the internet. So humans are providing data that are used by these algorithms. Of course, as you mentioned, at some point you want to see and you want to master the way that these AIs are behaving. You want to be sure that the insight that you get from this frontier model is relevant for your use case, and to make sure that it's not sidelining you to somewhere where you don't want to be. And to do so, you need to have a really good knowledge about these models. That's why we more and more try to use our own models. That Amiad signed a contract with Mistral AI, so that we have the option to either choose open model or choose proprietary models designed for military purposes.
Okay. I think in any case, I think this is the most challenging here because, of course, the algorithms of artificial intelligence needs to be trained. The quality of the data for this train is very important, he has told you. But at the end, it's the same question that before. how are you sure that the data that you are training the algorithm is okay? If you have provided because you have made a simulation, it's perfect, but in the real world, it's not so sure. For example, the civilian partners, the data from civilian partners are more exposed to cyber attacks. And in this case, it's possible to introduce some poisoning data, and that is a disaster for the algorithm at the end. So it's very important to train in the correct way to the algorithm, and I think that right now the decision or the result of this algorithm can help to the human. But I don't know if you agree with me, but to let all the decision to the algorithm, I think that we are not in that page yet.
No. Obviously, we're not in the moment in which algorithms are taking military decisions by their own. First thing first, we are more and more leaving some scope of decision to algorithm, which is sometimes good. For instance, to process invoices. This is something that you are very glad that sometimes a robot processes invoices instead of a sailor. To come back to the subject of cyber attacks, obviously, the more you use this kind of systems, the more exposed your systems might be to several new kinds of cyber attacks, etc. The most fundamental thing to, I think, bear in mind is that the AI revolution is a big step. This is what we've seen over the last 2 years. There are lots of challenges, sometimes even almost philosophical, to say how can you master this kind of AI? How do you cope with governance? How do you cope with cyber, etc.? The way of the Navy is to go through that step by step, and to have small steps. And we started this over 5 years ago. First with the mine warfare. The first sort of autonomous system that we had was the SLAM-F. So we started with this system. Now we have the Embark Data Hub. Next year we will have AI systems also in the HQs, also on more ships, and step by step, issue after challenge, we can adapt these kind of technologies that are coming in our lives very, very rapidly. The development is exponential, but to, as you mentioned, control the way it's used and be sure that in the end, human stays in control and stays in the loop for the military decision.
So you've mentioned quite a few challenges when it comes to AI, and primarily also how do you make sure that you trust it? Is this something that you're looking at in Indra? Is there already like a roadmap on how to address this challenge of trust and how to deal with all this?
Well, in fact, Indra has a specific area only for artificial intelligence, Indra Mine, and we are focused in all the challenges related with artificial intelligence. But we have, for the underwater domain, sorry, but I'm going to...
Makes sense.
I would like to point out that communications are difficult in the underwater domain. It's possible to have a lot of data, but at the end, this data must be passed to other centers. And how to do this? Normally, acoustic communication is the most used, but they have limitations for the bandwidth. And we are studying optical communications based on laser. We have an area focused on this. We are joined with universities and companies focused on the laser development to try to have more distance range for the optical communications. We are talking now about 50, 100 meters, being very optimistic. And I think that in the following years, as the technology is running so much, we are going to be able to have communication, an optical communication in a good distance. And this could improve, I think, a lot the seabed domain because the bandwidth is bigger than acoustic. That are the two main lines in Indra, and also the quantum technologies. I look to Madsense because we have been in a conference talking about quantum, also for aeronaval. And yes, it's a science fiction, but in any case, we are studying how to make communications more sure using this technology. So these are our main lines of development.
Okay, so in the future, what we can look forward to is making the seabed a little bit more transparent, using AI to also be able to fuse more data and sift through it, and then hopefully, not too far away, use quantum to secure all of this data and be able to trust it more.
Yes.
Okay, okay. What about on the French Navy side of things? What are we looking forward to in terms of like how to make the maritime domain, well, not more transparent, but you know, being able to see more?
Well, to come back to first, there are things that won't change. Naval warfare will still be very fast. It will take a lot of time to build up, and then it's very fast. It's destructive, and most of the time decisive. You don't really get the chance to have a second round. So that said, you will always have the same need to have intelligence, the same need to have command and control, and the need to have, in the end, firepower. What's changing today with the three main drivers that we see is really in command and control and intelligence. So all the maritime domain awareness, all the seabed warfare, seabed intelligence, etc., communications are really changing the amount of information that you get for intelligence and the amount of information that you need to process through your command and control to fire the torpedo or gain the naval combat. The three main areas in which we see things changing very fast is access to space. Say new space, but it's not really that new anymore. AI, we mentioned, and robotics. All these three drivers are really changing the way with which we gather intelligence and analyze information for seabed, for underwater warfare or above water warfare.
And I think this sets perfectly the scene for the next two talks that we will have in this series of EURONAVAL Talks, because we'll be talking, number 5 is going to be about electronic warfare, which is going to be about mastering the electromagnetic domain and understanding what's out there, what is a threat, what isn't. And I think the conversation about AI and trust is key also to that conversation. And then the final one, so the 6th talk will be on the high-low mix, which is going to be precisely what you said, the robotics and how do you decide to use which platform when and what to engage at which point, because we're not the only ones using robotics. Our adversaries are as well. So how do we decide to neutralize a robotic who's trying to find us? Well, we're coming to the end of our roundtable today. Time really does fly. It's been an absolute pleasure having you both here today.
Thank you.
It's been great seeing you exchange and seeing also this difference between also what's happening in Spain, in France. It's great. Yes, I'm really looking forward to seeing how this conversation moves forward.
Thank you.
Thank you so much, and thank you to the audience.